Next question is, if there are some sets given A, B, C and D, set A contains elements A, B, C, D, E, set B contains elements C, D, E, F, C contains B, D and D contains A, E, then which of the following statements are true and which are false? So only we have to decide the true or false statements amongst the following. The first statement is C is subset of B. So is it true or false? That we have to decide. So to be C subset of set B, each element at C must be in set B. So we'll check whether it is true or not. So in set B we have element B and D, out of which in set B uh, small b letter is not there. Element of set C is not in set B. That's why set C is not a subset of B. That's why this statement is false. Second statement is A is subset of D. So every element of A is not in D. That's why it is also not possible that A is a subset of D, and it is given that A is subset of D. That means the statement is a false. Third one is D is subset of B. So in set D we have elements small letter A and E which are not in set B, because E is there but A is not there in set B. That's why D is also not a subset of B. So the given statement is again false. The third one is D is subset of A. So every element of D, A and E are there in A. So we can say that D is a subset of A because every element of D is in set A. So the given statement here it is true. Next question is, take the set of natural numbers from 1 to 20 as a universal set and show set X and Y using Venn diagrams. Following the sets X and Y are given. So first of all, we have to write a universal set which is represented by U. So in this set we need all the natural numbers from 1 to 20. So the natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So this is the universal set. Now we have to draw the set or represent set X and Y by Venn diagram. First we have to represent the set in listing method. So here the set X is given in set builder method. We want here X belongs to N, that is we need all the natural numbers where 7 is less than X is less than 15. So we want all the natural numbers between 7 and 15. So the natural numbers are 8, 9, 10, 11, 12, 13 and 14. We cannot take 15 because we need strictly less than 15. So the curly bracket completes. So this is the set X, and set Y is equal to, here the property is given that Y belongs to N, that is again we want a natural number, and Y is a prime number from 1 to 20. So all the prime numbers between 1 and 20 we have to collect them in set Y. So the first prime number is 2, then 3, next to it 5, 7, 11, 13, 17 and 19. So these are the prime numbers which are less than 20. Curly bracket complete. Now here we have to represent these three sets U, X and Y using Venn diagram. So first, as we know that in Venn diagrams generally the universal set is represented by a rectangle. So this is the rectangle which represents universal set U. Now we want here set X which is a subset of U, as which is obvious, U is a universal set. Y is also subset of U because each set is a subset of universal set under the consideration. So in this rectangle we have to represent set X and Y. But before that First, we have to check whether there are any common elements in x and y. So as we can see here, 11 is common in both the sets. Then 13 is also common in both the sets. So if we represent one circle, if we draw one circle to represent set x and another circle to represent set y. So this is the common part. In this common part, we have to write the common elements, that is 11 and 13. Then consider this as set x. So other elements other than 11 and 13 in set x are 8, 9, 10, 12 and 14. So this is the set x. For set y, the common elements are 11 and 13, which we have already taken. Now the other elements are 2, 3, 5, 7, 17 and 19. So this is how we can represent a set x and y using a Venn diagram. Now there is another problem for you. If universal set U is equal to 1, 2, 3, 7, 8, 9, 10, 11, 12 and P is equal to 1, 3, 7 and 10, then show that the set U, P and complement of P by a Venn diagram. So I'll just give you a starter, that is set U is given. We'll write again 1, 2, 3, 7, 8, 9, 10, 11 and 12. Set P is also given, it is 1, 3, 7 and 10. From these two we have to find the complement of P, that is P dash. So complement of P, we represent it as those elements which are in U but not in P are complement of P. So the elements which are not in P but are in U are 2, 8, 9, 11 and 12. So these are the two sets P and P dash. You have to represent these sets by Venn diagrams. So try to solve or try to draw these Venn diagrams on your own. So this is for homework again. The next question is, if set A and set B are given, that is A is equal to 1, 2, 3, 4, 5, 6, 7 and B is equal to 2, 4, 6 and 8, then write the following sets. The first is A union B and A intersection B. So first we need A union B. In union of any two sets, we have to collect all the terms in the given two sets. So we have to write firstly the elements of set A, that is 1, 2, 3, 4, 5, 6 and 7. Then again we add elements of set B. So here the first element in set B is 2, which we have already taken. So we cannot repeat that element. Further we have 4, which is also we have taken. So we can skip it. Again 6 is also taken. So the only extra element is 8. So we can write here 8. So the A union B, that is union of these two sets are 1, 2, 3, 4, 5, 6, 7 and 8. So this is the first one, union. Now the second one, we need here A intersection B. So intersection stands for a common element. So we have to only find the common elements and we have to take those common elements in this set. So the common elements, as we can see here, 2 is the common element which is present in both the sets. Then 4 is also common and again 6 is also common. So these are the only three elements which are present in both set A and set B. So their intersection must be 2, 4 and 6, curly bracket, complete. Let us study the last point in this topic, that is number of elements in a set. So for this one, let us consider one example. Let us consider a set of 5 points, 5 numbers, it is 2, 4, 9, 12 and 17. So if, as we can see here, there are 5 elements in this set A, that's why we say that in set A there are 5 elements and we denote it as n of A, that is number of elements in set A, is equal to 5. So this is how we can calculate, or we can find the number of elements in any particular set. Now based on this, we have one property, that is number of elements in union and intersection of a set. So for this one, consider two sets A and B. Set A has elements 1, 2, 3 and 5, and set B has elements 2, 5, 7 and 8. Now first of all, we have to find their union. So A union B is equal to, as we know, we have to collect all the terms from set A and set B. So first we'll take the elements of set A, that is 1, 2, 3, 5, and then elements from set B, that is 2, which we have already taken, 5, which we have already taken, we add 7 and 8 to it. So this is the union of set A and B. Now next we'll find the intersection of these two sets, that is the common elements that they have. So there are only two common elements, 2 and 5. So this is the A intersection B. Now if we can count the number of elements in each of the set, so here we have n of A, that is number of elements in set A, is equal to, as we can count here, 1, 2, 3 and 4. N of B, that is number of elements in set B, are also 4. Then n of A union B, number of elements in set A union B, are 1, 2, 3, 4, 5 and 6. And n of A intersection B is equal to, there are 2 elements. Now if we write here n of A union B, so under that we'll write n of A union B are 6, that is there are 6 elements in A union B, that is equal to, now we can split this 6 as 4 plus 4 minus 2. So 4 plus 4, that will be 8, minus 2, again we will get the 6. Now if we represent 4 by n of A, as there are 4 elements in set A, so instead of 4 we write n of A, plus again number of elements in set B are 4, so instead of second 4 we write n of B, minus 2, there are 2 elements in a set A intersection B, so instead of 2 we can write n of A intersection B. So again here we will have, instead of 6 we can write again n of A union B, that is equal to n of A, that is number of elements in set A, plus number of elements in set B, minus number of elements in set A intersection B. So this is the formula, or this is the relation between number of elements in set A, in set B and in set A union B and A intersection B. So by this formula we can solve some examples. So we'll solve this example based on the relationship between the number of elements in set A, in set B and A intersection B and A union B. So we have the relation n of A union B is equal to n of A plus n of B minus n of A intersection B. So we have 4 variables here, out of which if 3 are given we can find the 4th one. So in this example we are given number of elements in A, number of elements in A union B and number of elements in A intersection B, and we have to find number of elements in B. So we'll replace the values. Number of elements in A union B are 29 is equal to number of elements in A are 15, plus we have to find the number of elements in B, so we take it as it is, minus n of A intersection B, that is 7. So if we simplify this one, we will get 15 minus 7, that's 8, plus n of B. If we transfer 8 to this side, it will become 29 minus 8, that's 21, is equal to n of B. That means number of elements in set B are 21. So this is how we can solve examples based on this relation. Let us consider another example. In a hostel there are 125 students, out of which 80 students drink tea, 60 drink coffee, and 20 students drink both tea and coffee. Find the number of students who do not drink tea or coffee. So for this example, there are two sets of students who drink either tea or coffee. So let us name those sets. Let A be the set of students who drink tea, and there are 80 students who drink tea. That's why number of elements in this set, that is n of A, is equal to 80. Let us give name B to the another set. So let B be the set of students who drink coffee. So there are 60 students who drink coffee, so n of B is equal to 60. And now there are 80 students drink tea and coffee both. That means 20 students are common for both these two sets. That means they must be included in the intersection, that is A intersection, n of A intersection B will be equal to 20. Now we have the relationship between n of A union B, n of A, n of B, and n of A intersection B. That is n of A union B is equal to n of A plus n of B minus n of A intersection B. So if we substitute the values, n of A is equal to 80 plus n of B is equal to 60 minus n of A intersection B is equal to 20. So if we go on simplifying, we'll get n of A union B is equal to 20. Now that means there are 120 students who drink either tea or coffee. But our question is, we have to find the number of students who do not drink tea or coffee. In hostel, there are 125 students. That's why to find the number of students who do not drink tea or coffee, we have to subtract the number of students who drink either tea or coffee from total number of students, and the total number of students are 125. So if we subtract n of A union B from 125, we'll get 125 minus n of A union B, just we have already found, that is 120, that is equal to 5 students. So that means there are 5 students in a hostel who do not drink tea or coffee. If you like the content, please subscribe the channel. Thanks for watching.